Okay, geometry. Here's the follow-up video just to go over these examples. I'll just let you know I'm in the middle of a Zoom meeting at the same time, so someone might chime in. I'm just giving a practice test to my AP Stats kids, but you might hear some voice come in and say, "Mr. Rollinger," and then I'll pause this. All right, so the whole key of this is just understanding this idea that you know what fraction of the circumference is, so you can just say that the arc length is 1/9 of the whole circumference. I don't do pi d, I do the 2 pi r one. I think it's just the way I learned it. 2 pi times r. I just learned it with 2 pi r, and so that's just the way I do the problems. And so this arc right here is 1/9 of the whole circle. That's all the formula is. It's just what fraction of the whole circle you have. And so you can answer this a couple different ways. I could cancel out the 9 and the 3. I'm doing cross canceling with fractions, and so you'd end up with an answer of 2 pi over 3, or you could just grab your calculator and say, that makes sense, and you could say, what's a 1/9 times 2 pi times the radius, which is 3. And so I'm getting that's about 2.09. Depending on what the problem says, if it just says find the answer, this is fine. If it says round to the nearest whatever, then you can use decimals if you want. So the formula then, so now I'm going to write the formula in official terms, and I want to put it up here just so I have it in the same spot. So the idea of the formula is that it's a fraction of the whole circumference. Okay? That's the arc. I could say arc equals. The arc is just a fraction of the whole circumference. Now, in symbol terms, what's the actual formula? The actual formula is that the arc length is, and so here's how we write it. We say, well, what's the fraction? It's going to be theta divided by 360. Like, you have whatever that central angle is out of the whole circle. So that's just the 40 over 360 we did on the first one, times 2 pi r. And again, you could say times pi d if you prefer that. So this is the arc length formula. And it's really, if you know the 2 pi r part of it, then it's a formula that's not, if you understand it, it's not that weird. It's not just like memorize this thing. It's like, oh, okay, it's just a fraction of the whole thing. Okay, I got that. You just would have to know the 2 pi r part of it. So now we can go to the second one. Diameter is 6, arc length is 15. What's the central angle? All right, we got a circle, and the diameter is 6. I don't like the diameter being 6. I'm going to change the problem because it's the same size as the other circle. So I'm going to make the diameter equal to 8, and the whole arc length is 15. So if I kind of look at it, it's like, I don't know, let's see, 8. So I'm going 8 around here, and then 8 around, I don't know. It looks like it's about maybe about this big or something. I'm just guesstimating it. I don't know what I'm doing. I don't know exactly how far it is, but I'm just guessing if this distance right here is 8, how far is 15? And I'm just going and trying to figure it out as best I could, just eyeballing it. I could tell it's going to be somewhere down there, because once you go 15 units, if that distance is 8, I can tell you're going to be down below, but I don't know exactly where. So how do I solve this? Just go back to the formula. The formula makes it really easy. So what do I know here? So let me write it down. Arc equals theta over 360 times 2 pi r. Right? All right, so what do we know? I know what the arc length is. I know the arc length is 15. I know what the radius is. The radius is, 2 pi r. I gotta be careful. The radius is 4 there for me. Again, you could have used pi d. I probably said that a little too much. And I just need to solve for theta. So it's just an algebra problem. Yeah. And so, for me, I'd multiply the 360 up. So let's see, so theta equals, I think I can do this in one step. The 360, I multiply by both sides, so that goes up. So it's 15 times 360. But the 2 pi r, I'd have to divide both sides to get rid of that because it's not in the denominator. It's just a regular number. So I have to divide by 2 pi r. So I do divided by 2 pi r. Make sure if you do this on your calculator that you divide by this whole thing. If you, here, I'll show you. 15 times 360, well, here, let me clear my screen first. 15 times 360 divided by 2 pi times, times 4. Doing good. 2 pi, times 4. I'll do it that way. I'm doing it wrong, but, so here's what I've got. Here's what I've got right here. This is wrong because it's dividing, stay on the screen. It's dividing by 2 and then multiplying by pi and multiplying by r. Like it doesn't know the whole 2 pi r is in the denominator. It just thinks the 2 is in the denominator. It takes you really literally when you do something like this. So when you're doing it on a calculator like this or whatever calculator, you just have to make sure you're dividing by that whole thing. Maybe you work out what 2 pi r is first and 15 over times 360 and then you divide them or something. On this calculator, you could do it with parentheses, giving you a sneak preview for next year when you start using this in Algebra 2 class. Or on this calculator, you can actually do it this way. And I'm just doing this to show off, just to, kind of be a jerk about it. It's kind of fun. Pi times 4. So you can actually write it like this. And have lovely fractions. Isn't that nice? And I get 214? What? Oh, this is the central angle. So if I'm saying what's the angle, it's like, oh, okay, what's this entire angle all the way from here up all the way to there? And it's like, oh, that totally makes sense that it'd be that big because it's a huge fraction. I can hear a little buzz. Hold on a second. Let me make sure my class is okay. All right, it's all good. So it's theta equals 214.9 degrees. Make sure you show really clear work on these problems. I want to see your formula. I want to see how you're working it out. I don't want to just have an answer. Just having an answer by itself is not good enough. Last problem I just want to show you is one of these sort of complicated ones. And we can just put it right here. And so this is a problem from the book. You've got a couple problems right next to it. And the key to it is just breaking it down into sections. For this one, I have to think, all right, I got to find this length, and I got to find this length, and I got to find this curve, and I got to find this curve. A couple circles at the end, half circles at the end, and then the two big parts. And so you're supposed to find the perimeter of the blue section. So it's the whole thing. It's everything. So I'd say, well, okay, so I know I've got, the perimeter is, I've got a 13, and then I've got another 13, and then I got to do the arc. Okay, so this arc here is a semicircle. So it's only half of the circle. So it's 1/2. That's the theta over 360. That's 180 divided by 360. 1/2 of 2 pi r, which is 2 pi times the radius, which was 3 again. Weird. Just weird then. And that was that one. But, I got to find this one too. So that's another, it's another one. So it's another 1/2 2 pi times 3. And I could grab my calculator and add all these up to find out what the answer is. But make sure you show it really clearly like this so I can follow your reasoning and you're being very clear to me on what you're doing. Now, some of you alert people out there might have said, oh, Mr. Ellinger, there's another way to do this. I've got my 26 for the top and the bottom, but then I've got a semicircle over here. Over here, and I got a semicircle over there. So if I've got two semicircles, that's one circle altogether, and I'd say, very clever, and you'd get the same answer that way too. That's it. I just thought, some people really don't like trying to learn from the book, and it's hard for them to focus in on like what are the important things. This is the big thing for us. It's just this stuff, and I'll send you out this note sheet so you have it too. If that's helpful for you. Excuse me. Want to make sure we introduce the vocab of a circle because it might have been a while for you or something like that, and make sure the formulas were clear. And I just want to make sure that sometimes students, when they see a formula in the book, they just memorize it, and they don't take a moment to say, okay, why should this make sense to me? Because I think with this formula, if you take that time to try to say, well, what is this thing saying? Then once you realize it, once you get it, then you're like, oh, this is like, I won't have to spend any brain space to memorize this like I would something that was completely abstract and I had no idea what was going on. Okay, that's it. It's your DLD is assigned and we got the projects going on. Make sure you ask any questions. Make sure you start early. You know, I can't guarantee I'll be available all the time to answer your questions. And so I really encourage you not to last minute it. Get it done early, give yourself some peace, kick back and enjoy your time done. And anyway, and that's it. So take care, and I'll see you next week. No class on Tuesday. Goodbye stuff then. But and I haven't decided if we're syncing on Wednesday, Thursday, or Friday and the following Monday. I haven't gone that far to next Wednesday yet. Okay, take care. Bye.